Welcome back, students. Today we are going to discussing about the refraction of light through a glass slab and also laws of refraction. In the last section we are already discussed about what is refraction and what is the reason for this refraction, or why this refraction taking place when light moving from one transparent medium to another transparent medium. In this section we are considering that change in path or the bending of light when it is moving from air to a rectangular glass slab. And based on that activity or based on that experiment, we are concluding about the path change when it is moving from air to this kind of a rectangular glass slab. Initially, we are considering a rectangular glass slab. Through this glass slab, a beam of light or a small beam of light is considered. Then from the other side, when we are observing the same light rays of the same light beam, what we can see, whether any path change can be observed, then if a path change takes place, and what is a common thing we can find out from this particular path change. Based on a simple activity, we are verifying this refraction through this rectangular glass slab. For that one, we are considering a rectangular glass slab, tracing the outline of that glass slab. After tracing the outline of this glass slab, just we are considering an incident light ray. Just we draw an incident light ray to the surface of that rectangular glass slab. Then in order to represent that incident light ray, we are placing two pins. In order to represent the path of that light ray, we are placing two pins in that line. After placing that pin, just opposite side of that one, opposite side of the glass slab, we are observing the pin which we are already placed on the other side. Through the glass slab, we are observing the two pins which we are already placed. Then we want to place another two pins in such a way that all the four pins should lie in a same line. Observing through the glass slab, we want to place another two pins, and while placing the other two pins, one thing should be keep in mind, while observing through this one, all the four pins should be lies in the same line. That means from observing the other end, we can possible to see only the last pin. The other three pins should be covered by the last pin. In the same line, that four pins should be observed. In that manner, we have to place another two pin on the other side. After placing that two pins, just removing the glass slab, then removing the pins, join the dots which we are obtained on that paper on the other side of the glass slab. And we will obtain just like this manner, a pattern will be obtained, and join in that line, we obtain the emergent light ray from that glass slab. Incident light ray is already being considered, this one, and now we obtain the emergent light ray by joining the dots we obtained by placing the pins. And we already know that in a single medium, light always travels in a straight line. So inside the glass slab, the light ray should be passed through a straight line. So we are joining the two ends of this glass slab with a straight line that indicates the path of light ray inside that glass slab. Now we will obtain this particular pattern. One light ray is considered as the incident one, and after refraction we obtain the emergent light ray on the other side. And after observing these two light rays, what we can see? In order to conclude this one, just extend the path of that incident light ray. If there is no refraction takes place, then the incident light ray should follow a straight line. Just we are extending with a dotted line that straight line path. But due to the refraction, that light ray changes its path and moves through another path on the other side that we already obtained. And by comparing these two paths, the possible path and the obtained path, we can see that the incident light ray and the emergent light ray are parallel to each other. And another thing we can do just to draw a normal line to both the surface of that glass slab where the light rays which we are considered. And after drawing the normal lines, we can possible to measure the angle between that normal line and the incident light ray, that we can consider as angle of incidence. And on the other side through which the light ray is emerged, that point also we can obtain an angle between the normal line and the emergent light ray, and that angle we can consider as the angle of emergence. After measuring these two angles, we can see that these two angles are always equals. The angle of incidence and angle of emergence are always equals. If we consider any other angle of incidence, then the corresponding activity if we considered again, then the same angle of incidence we obtain at the emerging side also. As the angle of incidence changes, the angle of emergence also changes. But in each situation, these two angles will be equal. And the incident light ray and the emergent light ray are always parallel to each other. And also, we can see that the incident light ray and the emergent light ray undergoes, or the emergent light ray undergoes a lateral displacement. That means it is deviated from its actual path. The main 3 points that we can conclude is incident light ray and emergent light ray are always parallel to each other. Angle of incidence and angle of emergence are always equal. The emergent light ray undergoes a lateral displacement. Next, we have to consider the laws of refraction. While taking place this refraction, here also two main conditions will be always satisfied, and that is termed as laws of refraction. So, whenever we consider this refraction, the light ray which is incident at the boundary of that two transparent medium is considered as the incident light ray. And the light ray which is obtained after the refraction is known as refracted light ray. And also we can consider a point of incidence at the boundary where the incident light ray strikes. That is the point of incidence. And also possible to draw a perpendicular line or a normal line at this point of incidence. So the incident light ray, and after refraction we obtain refracted light ray, and at the point of incidence we can draw a normal line. In every situation where this refraction takes place, this incident light ray, refracted light ray and the normal line always lies in the same plane. That is the first point of this laws of refraction. And here, between this normal line and the incident light ray, we can see an angle, and that angle is known as the angle of incidence. Angle between incident light ray and the normal line, that is known as the angle of incidence. And on the other side, angle between refracted light ray and the normal line is known as angle of refraction. In any situation where refraction takes place, the ratio between sine of angle of incidence to the sine of angle of refraction always gives a constant value. That is the second point of this laws of refraction. If we measure the angle of incidence and angle of refraction for an incident light ray, the ratio between the sine value of that angle of incidence and the sine value of angle of refraction gives a constant. This second point is also known as Snell's law of refraction. We can consider different angle of incidence for a pair of medium In each situation, we obtain different angle of refractions, but in each case, the ratio between sine value of angle of incidence and sine value of angle of refraction gives the same value. That's a constant value. So, the laws of refraction states that the incident light ray, refracted light ray, and the normal at the point of incidence always lies in the same plane. The ratio between sine of angle of incidence to the sine of angle of refraction always gives a constant. Then along with these laws of refraction, whenever this refraction takes place, here comes another two conditions. We are already learned that depending upon the speed of light, mediums are divided, or mediums can be considered as a denser medium or a rarer medium, in which light moves with maximum speed is known as rarer medium, and a medium through which light moves comparatively less speed is known as a denser medium. Whenever a light ray is moving from a rarer medium to denser medium, then it always bends towards the normal line which we are drawn at the point of incidence. Whenever the light ray is moving from a rarer medium to denser medium, it bends towards the normal line. And in the opposite case, that means if a light ray is moving from a denser medium to rarer medium, then it always bends away from the normal line. If the light ray is moving from a denser medium to rarer medium, it bends away from the normal line at the point of incidence. To remember that one, we can use a small trick. Means whenever the light is moving from a rarer medium to denser medium, we have to write it as R to D. While writing that last letter D, it is curved inward. That means the light ray bends towards the normal. And if the light ray is moving from a denser medium to rarer medium, we have to write it as D to R. The last letter R is writing, and the end of that letter is moving away. That means that light ray bent away from the normal line. While considering this refraction, one more thing you have to keep in mind that whenever we consider the refraction, the incident light ray should be obliquely incident on the surface. That is already we learn in case of reflection also. Whenever this light ray incident obliquely, then only this kind of a path change we can identify. Here exists a special situation. That means what happens if the light ray is incident normal to the surface or normal to the boundary between that two media. That means the incident light ray and the normal line will be the same. In that situation, what happens? Whether it is bent away from the normal or it is bent towards the normal. Then in this particular situation, whenever the light ray is incident normal to the boundary between that two surfaces, there is no path change takes place. That light ray should move through the same line, or it follows the straight line path.